All global warming is local in the sense we don't live in a global mean temperature or global mean sea level, so all the impacts are local manifestations of climate change, extremes, cyclones, everything is very local. So having action plans that also take into account this regional specificities of climate actions needed make a big difference. So we'll look at one example from the Kerala Climate Action Plan. Let me make sure. Oops. Why did it do that? Okay. Okay, here we are. Sorry about that. So the state put together a climate action plan. Actually, there's a complaint that it was done by outsiders, so maybe the state doesn't have ownership of it, but I'm not sure I buy that argument. If the state takes care to implement the action plan that is developed, then it's obviously their ownership of action. So this comes out of the Directorate of Environment and Climate Change, Government of Kerala, and it's focused on the period 2023 to 2030, which is great because this near-time decision making is fantastic, especially if you manage to reduce the global projections to the level, state level and at local levels. There are issues on how you would do that, but without worrying about that, if you have mitigation adaptation plans that take care of the known problems, then obviously it's going to work, and it will be a good example. Gujarat had an action plan also that was more than a decade ago, and I haven't done my homework to see if that has been followed and how many things have been implemented and so on. Just looking at the background, coming back to Kerala, there we are in the southern peninsular India, where Kerala sits with the coast to the Arabian Sea, has the Western Ghats running through part of it, and then has the peninsular part on the other side of the Western Ghats as well. And there are the district boundaries shown and the water bodies shown with some resolution, which we won't get into. So this is South Asia, India, Kerala, latitude of whatever, and we don't need to worry about those. The population is 3.34 crore. As you know, 1 crore is 10 million, so that's 33.4 million or so. So it's a well-known state for its natural beauty, for high education, for women being highly educated, and they migrate a lot to the outside world and do a lot of things that are considered progressive in the sense of women going out and working and bringing income, etc. So there is the elevation. So Western Ghats running down there at about 2,700 meters at its highest level. Physiographically, Kerala has three regions, namely Highland, Midland and Lowland, exhibits diverse geomorphic features such as the tall mountain peak of Anaimundi at 2,695 meters, 41 short run west flowing rivers and a coastal plain studded with several estuaries. The highland, greater than 76 meters, is the area in the eastern side of the state stretching from extreme north to the south, which follows a general trend along the Western Ghats. The Midlands, so 7.6 to 76 meters, just the physiographic classifications. This is the area between the highland and lowland, which is less than 7.6 meters, which matters when you think about sea level, storm surges, inundation, and so on, constituting undulated western fringes of the highlands and the lateritic rocky spurs pointing westward. The lowland is the coastal region consisting of interconnected brackish canals, estuaries, rivers, and are important for the state's economic activities, which we will look at. Land use pattern here, many changes. One of the more surprising ones is, of course, for 2021, these are land use patterns, not so much changes. So 2019-2020 data from this source here. So there is net area sown. Agriculture is important. Forest, land put to non-agricultural use, barren uncultivated land, land under miscellaneous tree crops, and so on. And you can see clearly that net area sown is quite large, and there are waterlogged areas, social forestry, still water, permanent pastures, and other grazing lands are non-existent. And if you look at district-wise per capita income, it's a relatively rich state. So you have various districts here, and the per capita income, the highest one for Ernakulam, without going into the reasons for it, is 180,000 rupees per year, which is fairly high considering the averages across India. So one of the surprising things that I started to say before is, if you look at area under paddy in terms of thousands of hectares, in 1980-81 it was over 800,000 hectares, and over time by 2012-2013 it was down to around 200,000 hectares and has remained fairly flat along the way. There have been various reasons why this has gone down, but we will not get into that detail, but we'll look at how the action plans relate to this later on. So obviously there is a trend in summer temperatures. Rainfall doesn't show a strong trend whether you look at the mean annual rainfall or the mean monsoon rainfall. So there is interannual variability. It has some part of the state get fairly good rain during the northeast monsoon, October, November, December time frame, as the winds sweep in from the northeast to the eastern side of the Western Ghats, and it also gets lots of pre-monsoon rainfall during March, April, May, and of course it has tremendous amount of rain in some parts during the June, July, August, September monsoon season. If you look at winter minimum temperatures, they have also increased, and you can see without being careful about the scales, winter is warming quite fast, and of course it has regional specificities in terms of cities versus rural areas, forest areas, agricultural lands, and so on and so forth. And the district-wise annual monsoon rainfall trend during the historical period, so you can look at monsoon and annual. Various districts, many places have negative rainfall trend for the annual as well as summer rainfall, and there are a few that have positive trends. So obviously the distribution of rainfall is not very homogeneous. It's quite uneven from the eastern side of the Ghats to the western sides, highlands, midlands, and lowlands, and also as you go from south to north. I have a couple of podcasts on why things have changed over the Arabian Sea, and the rainfall over the coast shifts from the south to the north. There are a couple of nice papers as well that you can look up. If you look at the total number of rainy days, I won't go into the details, but you can see that during the historical period and what will happen in the future. I'm not a big fan of periods beyond 2050 because the scenario uncertainties tend to dominate. The model uncertainties are generally the dominant issues to worry about during the next couple of decades. So if you look at the middle of the road representative concentration pathways and the business as usual scenario with the worst case warming for 2021 to 2050, there are shifts in projected rainfall days for those decades. You can see some regions will increase and extend, and in this case also it will extend north and south as well as east and west. And this is of course there are uncertainties, especially because models tend to say if there is global warming, land has lower heat capacity, so land will warm faster than the ocean and it will increase the monsoon strength. But of course aerosols have not done that during the historic period, so we have to see what aerosols will do in the future. But total number of extremely heavy rainfall days during, so they do heavy rainfall, very heavy rainfall, extremely heavy rainfall, and so on. I just picked one of them. Total number of extremely heavy rainfall days during the historical and projected near-term and mid-term periods under the two scenarios we looked at. If you don't know what is RCP 4.5 or 8.5, I have podcasts you can look up for those. So there is the historical period. You can see that number of extremely heavy rainfall was essentially very low, less than 15 per season. So this is during the year, but it doesn't matter. Most of the heavy rainfall happens during the pre-monsoon and monsoon. RCP 4, so that's the historic period. Both RCP 4.5 and 8.5 for the near term show increases basically across the state, except for a few places where the increase is not projected. But if you look at heavy rainfall and very heavy rainfall, you will get that already during this period there has been an increase in heavy rainfall and very heavy rainfall, and there have been floods. 2018, I think, was a historic flood, or I may be mistaken. You can look it up. I have it elsewhere. Initial list of indicators recommended by sectoral experts to represent the current composite vulnerability of Kerala. I won't go into the details, but if you just look at population density, it's sensitive. Percentage of the total population below poverty line, sensitivity is there in terms of vulnerability. Percentage share of natural resources based income, percentage of the total population that are inherently sensitive, so below 6 or over 65, air quality index, ground water quality index, and so on. So number of indices, number of parameters tend to get picked up to compute the overall vulnerability indices, and this is a complicated business. It's a very statistical business, but overall, when you want to think about risks, it'll be a product, as IPCC has formulated, a product of the hazard like extreme rainfall, cyclone, etc., and vulnerability and exposure. So exposure is, it depends on the infrastructure, population density, and so on and so forth. Okay, so district-wise composite vulnerability index, which combines those indices that we parameters that we looked at. So you can see that large parts of the states have high combined vulnerability, and a couple of districts here have low vulnerability, and a couple of them have medium vulnerability. So the idea of climate action leading to reduced vulnerability then becomes easy to track as well. So greenhouse gas emissions in million tons of CO2 equivalent obviously have been increasing just as everywhere else, and you can see that transportation has increased quite a bit. Buildings have remained almost the same. Industries have increased a slight bit, and there is public electricity generation and others contributing to this increase over time as well. And source-wise grid connected installed capacity, large hydrothermal and renewable energies. Renewable energies show some increase from 2015-16 to 2020-21, but large hydros have done most of the work and will probably continue to do that for a while. Okay, and of course there are thermal, which are high emitting ones, which are not reducing, which one has to worry about, of course, in terms of climate action. Policies in Kerala between 2015 and 2019. I won't again read all the details, but if you look at renewable energy based electricity generation, major policies and programs and schemes: Kerala Solar Energy Policy, development of wind farms in private land in Kerala, subsidy schemes for government producers, photovoltaics, and so on. Urja Kerala mission, and so on. So obviously there have been a number of policies for electricity generation, transmission, distribution, and they have done it for multiple sectors, for power, agriculture, and so on. And the report also maps these onto how they correspond to the nationally determined contribution submission India made under the Paris Agreement, and also how they map onto the sustainable development goals, which focus on poverty, education, water, energy access, health, sustainable use of water, etc., etc. So good that there is this policy activity always there. Kerala is one of the most progressive states when it comes to worrying about climate change, trying to use climate predictions to make decisions, especially on floods, which they have been getting hammered by recently, and so on. So normalized investments and normalized emissions, these are kind of numbers that will tell you how these have the potential for decarbonization. So you can see that if you want normalized emissions, so EE lighting, EE industry, EE appliances, buildings, solar power is up here, improvements in transportation, and so on, and renewable energies, etc. So all these things are there and they are thought about, which is good. Qualitative representation of greenhouse gas mitigation potential versus efforts required for activities not quantified. So you have pumped hydro and battery requirements, and renewable energy pilot emerging technologies, and so on and so forth. So greenhouse gas emission reduction potential is shown and the effort required is shown. So RTPV resource potential assessment has high potential but requires high effort. For example, improving EE of the non-PAT industries has a very high potential but also requires high effort, and so on. So lots of details are taken into account and should lead to some good action, which will be seen very quickly because the plan starts next year and will go till 2030, and there will be many evaluations, monitoring and reporting along the way, I'm sure. Proposed projects, objectives and actions for agricultural sector. Looking at the policies and then moving to proposed projects and objectives and actions. Again, multiple sectors are looked at. I'm just picking example sectors. So it's looking at vulnerable districts, projects and objectives, and sustainably enhancing agricultural productivity. So there are high and medium vulnerable districts identified, and planned activities and priority districts implementing agencies are all identified, and sustainably enhancing agricultural productivity with different timelines coming with different amounts of investments. So you can think here crop suitability assessment and productivity zoning. So mapping the least productive farmlands. This is for all of Kerala. It will be handled by Department of Soil Survey and Soil Conservation, and these are the kind of fundings that will go on till 2030-31, amounting to 3.1 crores, which is 30 million rupees. And so there are similarly other actions here. I won't go into the details because the report is relatively long and detailed, but I want to give you a flavor of the kind of issues that are considered, the kind of details that are mapped out, and the kind of detailed policies and actions that are mapped out, and the fundings that have been identified as well. So modernization and integration of various technological systems by the Forest Department at various levels. So multi-purpose web GIS systems for forest management, enhanced forest database management system for the state, automated weather stations at various locations. So you can see the amount of money that goes into it, and strengthening participatory forest management and livelihoods and such. Air quality management, monitoring of climate sensitive diseases, which will be done for all of Kerala, focusing on obviously air quality, comes with funding which will include monitoring, modeling, predictions, early warning systems, and so on. So there are other adaptation projects with identified funding amounts mentioned here. Improving green cover and forest protection, so that's under forests and biodiversity. Health, for example, targeted health care for sensitive populations, increasing access to functional health care. And you have things like air quality management and monitoring of climate sensitive diseases. With warming and increasing humidity, this is going to be more and more of a serious issue. In water, again, lots of funding for things like sustainable access to safe drinking water in the priority districts, and they are all also identifying potential sources of adaptation finance. So amount needed, where the money could come from, and hopefully this will just get implemented systematically and show very quick results. Proposed institutional mechanisms here: Chief Minister's Governing Council on Climate Change. Always good to have a council that monitors progress, implementation, finances, environment, sustainability, governance, all the kind of things that happen at such large scale funding and project implementation in diverse sectors with many stakeholders. So state level steering committee with an advisory committee giving feedback. State climate change cell interacting with working group, research, strategic partnership, training and extension. Sectoral climate change cell. And there is the LSG working group that will work with district climate change cell. So large scale group, working group adaptation, working group on mitigation, and so on. Illustrative results framework: sustainably enhancing agricultural productivity. I'm just using these as examples because these are done for each sector: power, water, agriculture, and so on, biodiversity, and so on. Okay, so project development indicators are identified, baselines are going to be set. There is funding, farmers increased, income increased, so estimates for 26 and 30. So you can see estimated to go from average of 50,782 rupees to 55 over almost 56 and 63 and a half. Okay, so there are carbon sinks created and emissions mitigated, looking at those into the outer years after the baseline. Percentage of farms provided with soil health card, so you can see the kind of details. They will start with 10% in 23 but jump to 50% by 26 and 100% by 2030. So really laudable details in terms of the planning and the quantitative metrics that have been set up for everything. Obviously it's a very brief introduction. It's a report that's, I think, almost more than 300 pages long, and if you want, there are many tables, many references provided, many details that I haven't gone into, but please go ahead and grab that report online if you're interested in more details, or using that report as a basis to plan climate action in your region, in your state, and so on and so forth. Okay.